Hello everyone, welcome to my YouTube channel. Today I'm going to be solving the Neet abroad paper for physics. Let me start off with a question. The first question is based on the concept of self-inductance. The current in an inductor of inductance 4 Henry changes from 4 ampere to 2 ampere in 1 second. The EMF induced in the coil is, we know EMF induced in the coil is equal to the rate of change of flux, that is the negative of rate of change of flux. The negative sign can be explained by Lenz's law, but for now it's easier to just put the negative sign and do it directly using Faraday's law. So it's minus d phi by dt, and we know phi here in the case of self-inductance is equal to Li, so it is minus L di by dt. So it is minus 4, and the rate of change of current is minus 2 ampere per second. So we get the answer as 8 volt, which gives us the answer as option 4. So the fourth one is the right answer for the first question. Now the second question asks us the correct statement about the variation of viscosity of fluids with increase in temperature is. We know viscosity of fluids, that is the liquids will decrease with temperature, increase in temperature, and for gases will increase. Why will it increase for gases? Because the kinetic energy of the gases will increase, so the or there is more resistance to flow now compared to that of liquids, where there was a streamlined there was a normal like a resistance to flow, but here now since the velocity increase they are more random compared to previously, so there's less resistance. But for gases they were already random, so therefore with increase in their kinetic energy there is more resistance to flow. Why? Because they can collide easily with each other now. So therefore the second answer should be option 4, because that only matches. Viscosity of liquids decreases and viscosity of gases increases. Now third one, we know the de Broglie wavelength of a thermal electron is at 27 degrees Celsius is lambda. When the temperature is increased to 927 degrees Celsius, its de Broglie wavelength will become. We will know lambda is equal to h by mv. This is momentum, and this is an electron. An electron is not like a photon. Electron has mass, so we can write it as p square by 2m, not taking relativistic effects into account. P square by 2m is equal to kinetic energy. You know kinetic energy is 3 by 2 kb times t. 3 by 2 times kb times t. So we know momentum is equal to root of 3 m kbt here. Why 3 by 2 kbt? This is the translational kinetic energy. So lambda is equal to h by p, which is h by root 3 m kbt. So we can see lambda is inversely proportional to root of temperature. Initially the temperature was, so lambda 1 by lambda 2 will be equal to root of T2 by T1. We have to do this in Kelvin because it's a standard temperature unit. Initial temperature was 300, so since it's inversely proportional to root of temperature, should put it here. Final temperature is 927 plus 273 in Kelvin, that is 1200 Kelvin. So we get as root of 4, which is equal to 2. So lambda 1 by lambda 2 is equal to 2. So the first one they have given us lambda. Since the temperature is increased because lambda by 2. So third answer is option number 3. Now moving on to the fourth question. Now the fourth question, assuming the earth to be a sphere of uniform density, its acceleration due to gravity acting on a body. If the earth was not of uniform density, then what would happen? Then we have to integrate, take an element and we need to integrate to find out If you remember, we had Gauss law for electrostatics. We can do it in a similar way to find out the gravitational field. Here using Gauss law for gravitation using analogy. How do we do that? We tell you. In electrostatics we had integral E dot dA, that is integral of the flux d phi over a closed loop, is equal to charge inside by epsilon naught. Here we can use epsilon naught corresponds to 4 pi g in gravitation and q corresponds to charge. You can do as g dot dA over a closed loop. If you want to integrate, if the gravitational field is not uniform. But here for a particular dA element it is uniform, so we can take it out here. How do we take it out? Let me show you. If it was actually for this question it is not required, but let me just illustrate. Suppose we have a sphere like this and we want to find the gravitational field at a point inside at a distance r by 3 from the center of the earth. Distance r by 3 from the center of the earth. We know here g times the g can come out since it's uniform for this all the elemental areas on this spherical surface. So g times the area, which is 4 pi r square by 9, is 4 pi g, the mass of the earth inside this sphere is not like that completely, rather the mass is like we have to find the mass, which is, we know mass is proportional to volume. That is, why is it proportional? Because mass is rho times v and the density of the earth we have assumed to be uniform here. Otherwise we need to integrate, we need to do rho dv for that, and we need to find the integral and we have to put m there. So mass is proportional to volume, so r by 3. For r radius we have a mass of capital M, which is, that means m is proportional to capital R cube. So for r cube by 27 like volume, we will have m by 27 mass. So 4 pi we can cancel, so we get it as gm by 3 r square is the answer. Or we can just evaluate using the graph that we already know. This is the graph. We know it is gm by r cube times r. It is proportional. So if you put r as small r as r by 3, we'll get it as gm by 3 r square. So this question is pretty straightforward. It's independent of the mass of the body. Since we know force experienced by the body or the weight is equal to m times g, the acceleration due to gravity is always dependent on the mass of the earth, not the mass of the body. So the answer for the fourth one is option 4. Increases the increasing altitude? No, it increases up to a distance and then after that it decreases. Increasing depth? No, it decreases with increasing depth. Is independent of the mass of the earth? No, it is dependent on the mass of the earth. A particle of mass 4 m kg splits into two particles of mass m and 3m. The ratio of the kinetic energy of mass m and 3m would be. Okay, this question involves a conservation of momentum. Why do I say it involves a conservation of momentum? Because the total external force is 0, because it's an kind of an explosion if you think about it, since it splits into two particles of mass in the ratio of 1:3. Now it was initially at rest, so the initial momentum was 0, 4m into 0. So initial momentum is 0, which is equal to, they've just asked the kinetic energy. Directions will be different, of course. mv1 vector plus 3mv2 vector. If you can see, mv1 vector minus 3mv2 vector. right? We can find v1 vector is minus 3 v2 vector. We do not know the direction in which if we assume in the same straight line, we can just write it in the magnitude terms in the opposite directions. Or a better thing to do is, since the momentum of this two is 0, this momentum should be the negative of the other momentum. Magnitude wise, these two momentums must be equal, right? Magnitude wise, these two momentums must be equal. We know kinetic energy of a particle can be written as p square by 2m. Since both their momentums are equal, kinetic energy is inversely proportional to mass. Since it's inversely proportional to mass, the ratio of kinetic energy of capital M and 3m, that is kinetic energy of capital M mass by kinetic energy of 3m mass, is inversely proportional to mass. So it will be 3:1. So answer is option 1. Now if you go to the sixth question, during simple harmonic motion of a body, the energy at the extreme position is both kinetic and potential is always either purely kinetic, purely potential. We know at the mean position we could have some potential energy because we have not defined the zero level for the potential energy. But we know the potential energy there should be minimum. Whereas if you see in the extreme position, kinetic energy is always zero and the potential energy is maximum. So the energy at the extreme position is always purely potential. So sixth one is option number 4. Now seventh one is based on Bernoulli's principle. Seventh one is based on what? It's based on Bernoulli's principle. We know according to Bernoulli's principle, the pressure energy per unit volume, the kinetic energy per unit volume, and the potential energy per unit volume is constant. This is basically a statement of energy conservation. Why do I say that it's a statement of energy conservation? Because everything we are dividing with the same quantity to make it a constant. Already it was a constant. Total energy, mechanical energy is conserved here. We just did it as total mechanical energy per unit volume is conserved to make the question a little easier for us. So the answer here is P plus half rho V square plus rho G H is equal to constant. Seventh one answer is option number 1. The ratio of the moments of inertia of two spheres about the diameter having the same mass and the radii in the ratio of. After integrating and finding the moment of inertia of a sphere, we know the moment of inertia of a sphere is equal to 2 by 5 mr square, right? About the diameter of the sphere. About the tangent, what will it be? We have to use parallel axis theorem and we need to find out. It will come out as 7 by 5 mr square, because parallel axis theorem states that the moment of inertia about that particular axis that we want to find is the moment of inertia of center of mass plus m into the distance squared from that axis. Okay, now they have given the ratio of the radii as 1:2. We know both are spheres, so this 2 by 5 quantity is not going to change and they have the same mass. So moment of inertia is directly proportional to r square. So the ratio of their moments of inertia should be 1:4. Now, ninth question is quite an interesting question, and if you see on the sides, I've written M, E, E. These are all in the ratio of the difficulty levels. M is for medium and E is for easy. And today I will only be doing the section A for physics. A standing bus of the Neet foreign paper. A standing bus suddenly accelerates. If there were no friction between the feet of the passenger and the floor of the bus, the passenger would move back. Why is this so? This is because of the law of inertia. Because the standing bus suddenly accelerates. If you see, you can also think of it in the case of a pseudo force. If there were no friction, then for a person standing in the bus, you would observe another person standing in the bus as moving behind. That's the reason the passenger would move back. Or you can also think of it in terms of the law of inertia. Since it wants to remain at rest, it wants to oppose the change. Since the change is acceleration forward, it wants to go behind, so that it can remain at rest as it was previously at rest. In the absence of friction, the floor of the bus would slip forward under the feet of the passenger. In the absence of the friction, the floor of the bus would slip forward under the feet of the passenger. Yes, this is absolutely right. In the absence of friction, the floor of the bus would slip forward under the feet of the passenger. Yes, because he is going backward, the bus is going forward, so therefore there is a slipping in the direction of the forward between the foot and the passenger's feet. So the statement 2 is also absolutely right. Yes, because the person's feet moves backward, that's why the slipping occurs in the forward direction. Therefore the assertion and the reason are correct statement, and the reason explains the assertion. So option 3 is right for the ninth one. Okay, let's move on to the 10th question. The 10th question is clearly based on Malus law. Here it says linearly polarized monochromatic. That means it's already polarized. If it was unpolarized, then I need to do it as, let's say, an unpolarized state of I0 comes through. This is a polarized having pass axis like this. It's polarized having another pass axis like this with an angle theta. Then after this, it only cuts light in this direction. That means only electric fields in this horizontal direction it allows. So there were equal electric fields in the horizontal and equal in the vertical direction. Let's assume that I0 by 2 light intensity comes out of the first polarizer. Then second polarizer makes an angle theta. According to Malus's law, we will get the final intensity to the analyzer, we call it the second polarizer, as I0 by 2 cos square theta. But here it's already polarized and it's landing on a polarizer. So for the 10th one, we can directly solve it. So 2.5 is the final intensity coming out. It is equal to the initial intensity which is coming into the polarizer times cos square theta, which is the angle between the direction of polarization of the light and the polarizer that we need to find in this question. So 1 by 4 is equal to cos square theta. So we get theta as equal to 60 degree, because half is equal to cos theta, and we get theta as 60 degree. It actually gets plus or minus half, so we have to do it based on quadrants, but here they have given us only one option. So, or we can go in the anti-clockwise or clockwise direction depending. So therefore here they have given only one such possible solution, so we choose that as the answer. So the answer is 60 degree for the 10th question. Moving on to the 11th question. If you see the 11th question, ratio of the radii of two circular coils is given, and the ratio of currents in the coils has the same magnetic moment. Magnetic moment is current times area. So therefore, we know that their magnetic moment should be same, and since the ratio of the radii has been given, we know the ratio of the areas. If the ratio of the radii is 1:2, area is proportional to radii square. So area ratio will be proportional to radius squares ratio, which will be 1:4. So that's the ratio of the area. Since Ia is equal to same, that is Ia is equal to constant, if the area increases, then the current should decrease. So the current ratio will be ulta of the area ratio. So the current ratio should be 4:1. Let's move on to the 12th question. 12th, we know that gas undergoes an isothermal process specific heat capacity of the gas in the process is? The answer will be infinity. Why? Because the change in temperature here in isothermal process is 0, and we know the heat gained in a process is equal to, let's say in random process, is nc times dt. Since dt is equal to 0, I need an infinite change so that this can become a value. So heat has a value. Why heat has a value? Heat is not equal to 0 in an isothermal process, so the answer should be infinity. Or we can also solve it by this method. We know for a polytropic process, the heat capacity is equal to Cv plus R by 1 minus N, where for a polytropic process, PV power N is equal to constant. We know N is equal to 1 in an isothermal process. So R by 1 minus N, R by 1 minus 1, so R by 0, which is infinity. So heat capacity comes out to be infinity. The 12th question. Now the 13th question is an interesting question based on transistors. In this question, two amplifiers of voltage gain 20 each are cascaded in series. In series, their currents must be the same if they were resistors or any such object, any such electrical device. If 0.01 volt AC input signal is applied across the first amplifier, the output AC signal of the second amplifier in volt is. We know here, since there are two amplifiers, let me draw two transistors. Series, suppose they were like this. We can see the input of this is 0.01. So the voltage gain is given. So 0.01 into 20 times will be the output voltage coming out from the first amplifier. So 0.01 into 20 will output voltage will be coming from the first amplifier. This output voltage will be the input voltage for the second amplifier, because it will be like this, somewhat like this, the circuit. This is the input voltage for the first amplifier. This is the output voltage for the first amplifier, will be the input voltage for the second amplifier. So 0.01 into 20 is equal to input voltage of the second amplifier or the output voltage of the first amplifier. Is equal to input voltage of the second amplifier. So then it will again get amplified by 20, because both the amplifiers have the same voltage gain. So 0.01 into 20 into 20 will be the output voltage of the second amplifier, which is what they're asking the question. So 0.01 into 20 into 20. 20 into 20 is 400. 400 into 0.01 is 4. So 13th one is option number 2. Let's move on to the 14th question. Put in the hollow metal sphere of radius r is given a plus q charges to its outer surface. The electric potential distance r by 3 from the center of the sphere. We know in a hollow metal sphere, the charge can only be distributed on the outer surface, so the electric field inside is 0. Therefore, the potential inside to the surface is constant. That is, it's an equipotential surface. So potential outside is same as the potential inside, that is kq by r, which is q by 4 epsilon pi epsilon naught r. So the answer is option 4 for this question. Now the dimensions of mutual inductance for the 15th question. We know that flux is equal to mutual inductance times current. So mutual inductance is flux per unit current. We know flux is equal to B times area. In terms of dimensions, we are not taking into account the number of turns. BA by A, current. And now we know force is equal to BIL. So the dimension of magnetic field is F by IL into I into area. Dimension of area is L square. So we will get the dimension of mutual inductance as FL by I square. FL is nothing but force into length, which is the work done, which is equal to energy. So we just get it as FL by I square is equal to mutual inductance dimension of mutual inductance. So FL is nothing but energy. We know dimension of energy is ml square t power minus 2 by the dimension of current is a squared, which is dimension of mutual inductance. The dimension of ml square t power minus 2 a power minus 2 will be the right answer. Now there is another method to solve this question. We know the time constant is L by R, which is time. So L is by R is equal to time constant. That means time constant dimensions is the dimension of time. So the dimension of self inductance will be the dimension of resistance into the dimension of time, basically. The dimension of resistance is nothing but voltage by current, so we can do it directly by this method also. And voltage also has a dimension of current a power minus 1 coming, so this will add another a power minus 2, so we can do it by this method also. Moving on to 16 question. 16 question is direct question based on Ohm's law. You know V is proportional to I at a particular temperature for a metallic conductor with uniform cross section. So the answer for this will be option number 1. That is I is proportional to V graph, which is a straight. So I was in the 17th question. A network of resistors connected across a 10 volt battery with internal resistance of 1 ohm is shown. The equivalent resistance circuit diagram is. Here we know we should not count the resistance of the cell in the question because it's not part of the equivalent resistance, rather it's an internal resistance of the battery. Now the equivalent resistance of the question, we have to take 2 ohm and 4 ohm in parallel, in series with 2 ohm, and in series with another 2 ohm and 4 ohm which is in parallel. So the 2 ohm and 4 ohm in parallel, we can just directly do it. As we know, formula for R equivalent is R1 R2 by R1 plus R2, which is 8 by 6, which comes out to be 4 by 3. So we have 2 times of 4 by 3. Since in series we just need to add the resistance plus 2. 8 by 3 plus 6 by 3, which is 14 by 3. So we get the answer as option number 2 for 17th question. Moving on to the 18th question. 18th question, we can do it directly here itself. When a body of mass m just begins to slide, as shown, match list 1 with list 2. Normal reaction we know is Q. It is perpendicular to the surfaces in which are contact, perpendicular to the surface in which it is in contact. Frictional force is opposite direction to which it is going to slide, which is to the direction of mg sin theta. So mg sin theta is P. So D is option 1. So we have D is 1 and 2, 3 and 4. Option 1 is ruled out. We have frictional force is R. So B is 3. So option 2 is also ruled out because in option 2 it says B is 2. And option 3, normal reaction is S. No, normal reaction is not S. Normal reaction is Q. So option 3 is also ruled out. Option 4 is the right answer, which is normal reaction is equal to Q and S is nothing but our weight mg. So C is 4. So option 4 is the right answer for the 18th question. An inductor of self-inductance then Henry carries a current of 1 ampere. The magnetic field energy. So the field energy stored, how do we find it? We know the field energy stored is half Li squared. How do we find this half Li square? We know that the EMF is magnitude is L di by dt, and we know the power is nothing but E times I, which is L I di by dt, right? L I di by dt, L I di by dt. Now, which is equal to the power, and no power P dt is nothing but dw, because power is dw by dt. So dw is L I di. Now I just need to integrate it. I get the work done is half Li square, which is used to make it store energy of this much, since its initial energy I assume to be as 0. So half Li square, which is half into 10 into I square, which is half into 10 into 1, so we get the answer is 4. Now the 20th question. So the 20th question is a direct question based on the color code of carbon resistors. How do I solve this? We have to remember mnemonic. B.B. Roy of Great Britain had a very good wife who had a gold silver necklace. So B stands for black, then brown, then red, orange, yellow, green, blue, then we have like gray and white, then silver and gold in terms of tolerance. So the first two indicate the significant figures, the third one decimal multiplier, and the fourth one is the tolerance. If I see the orange and blue, according to the mnemonic B.B. Roy, we know for black it is 0, which is the significant figure. For orange it comes out to be 3, so we first write it as 3, and for blue it comes out to be 6, so we write it as 6, and the decimal multiplier for yellow comes out to be 10 power 4, so 36 into 10 power 4, and error will be plus minus 5% for gold. So we can take 10 power 4 outside as 360 kilo ohm, and 5% of 360 is 18, so the option 4 is the right answer. Now moving on to the 21st question. The 21st question, we know power can be simply added since it's a direct scalar, and power of lenses is additive in nature. Now we know power of a concave lens should be negative, and since the focal length of concave lens is negative, so we can directly add it, and focal length of a convex lens is positive. Power is minus 1 by 0.25, because power in diopter they are asking, which is an SI unit. You take the focal length in meter, plus 2 by 0.4. Why 2 by 0.4? Because two convex lenses are there. So 2 by 0.4 is 5, and minus 1 by 0.25 is minus 4. Minus 4 plus 5 comes out to be 1 as the answer. So answer for the 21st question is option 3. The next question, the 22nd question, is an interesting question to think about. A beam of light is incident vertically on a glass slab of thickness 1 centimeter and vertical and refractive index 1.5. Fraction A is reflected from the front face, while another fraction B enters the slab and emerges after reflection from the back face. The time delay between them is. How do I approach this question? First, let me draw the diagram. So this is the glass slab. I am drawing it in 3D. This is the thickness of the glass slab. Let's say light was incident. This is a beam of light, so they are incident in different angles. I'm using two beams in two different, because I don't know a proper direction of the beam, but let me choose this as beam 1 and beam 2. Just two random beams I have chosen. And then a part of it gets this is the normal, a part of it gets refracted the surface and gets reflected again. Now they are asking the time delay between the refraction that occurs in the surface and the reflection that occurs at surface B, right? We know they're asking the time delay between the refraction that occurs at surface 1 of the surface A of the slab, and at the back surface, let me call it as B, reflection at the back surface of the slab, because fraction B is the part that gets refracted from the first surface. That's the one which gets reflected in the back surface. So they're asking the time difference between the reflection at the second surface and refraction at the first surface. How do I find that? I just need to find the time taken by the refracted ray from the first surface to travel to the second surface. Then I get the time delay between the two. See, I know that the speed of light in the medium will be equal to the speed of light in air divided by the refractive index. Speed of light in air is 3 into 10 power 8, or vacuum more specifically. By 1.5 I get it as 2 into 10 power 8, which is the speed of light in this medium. And they have given the thickness of 1 centimeter. So the time taken is the distance by the velocity, which is equal to 1 centimeter. In SI units, if I take, it's 1 into 10 power minus 2 meter by 2 into 10 power 8 meters per second. So we get it as 0.5 into 10 power minus 10 meters, 0.5 into 10 power minus 10 seconds, sorry, which is the time, which is 5 into 10 power minus 11 seconds. So answer is option 4. Now at some instant, the number of radioactive atoms in a sample is n naught. After time t, the number decreases to n. It's found the graphical representation on n versus t found along the y-axis and x-axis as a straight line. Then slope of the line is, we know n is equal to n naught e power minus lambda t. That lambda is the decay constant. Now taking ln on both sides, I get ln n is equal to ln n naught minus lambda t, using the property of logarithms here. And here we are plotting a graph of ln n versus t. This is like y is equal to mx plus c, where the y-intercept is ln n naught. The slope here is minus lambda. So 23rd answer is option 2. 24th one, the circular scale a circular scale of screw gauge completes 2 rotation, covers 1 millimeter of the pitch scale. Total number of circular division 50. The least count of screw gauge is pitch by number of circular divisions. You know that it is pitch by number of circular divisions, the least count of a screw gauge. Pitch is the distance traveled with the screw gauge in one full turn. In 2 rotations it travels 1 millimeter. So in 1 rotation it travels 0.5 millimeter, which is the pitch of the scale. Least count is equal to pitch by number of circular divisions, which is 0.5 by 50. 0.5 into 10 power minus 3, because they're asking SI units. So 0.5 into 10 power minus 3 by 50 comes out to be as 10 power minus 5 meter as the least count of the screw gauge. So answer for 24th one is option number 2. Now if I move on to the 25th one can be done using work energy theorem or principle of energy conservation. Principle of energy conservation, since the other one is massless, here energy is conserved. The spring is massless spring, so the energy is conserved here. Otherwise we need to use momentum conservation and proceed in a different way. Whereas here, if I do this question, I just need to directly apply energy conservation. Initial energy is half mu square. Final energy is when it is fully compressed, the block will have zero velocity because the force will be pushing it back. When it has initial velocity u, there will be a force of kx pushing it back when it is moving forward, so it has to come to zero velocity at that a point of time. So therefore that will be the time when there is maximum compression. So the initial kinetic energy, that is half mu square, is equal to the spring energy that is present at the end, which is equal to half kx square. So I get the maximum compression x is equal to u root m by k. So answer for the 25th one is option number 1. Now moving to 26th one is a direct question based on electromagnetic waves. You need to remember the chart there and also the order of magnitude to which the values vary. The wavelengths of X-ray, infrared, microwave and gamma rays are given. So wavelengths I need to find. The wavelength of radio waves is greatest, then microwaves, then infrared, then X-ray, gamma ray. So therefore the answer should be wavelength of microwaves is the greatest, then that of the infrared rays, then the X-ray, microwave, infrared, X-ray, then gamma ray. So 26th one will be option number 1. Now moving on to 27th one, 12 point charges each of charge q are placed at the circumference of a circle of radius r with equal angular spacing. Equal angular spacing means they make the same angle with each other consecutively. Make it same angular spacing with each other. Same angular spacing. Same angular spacing with each other consecutively. 12 point charges each of charge q are placed at the circumference. So they make an angle 30 degree with each other. And since we know 12 charges are placed equally at an angle of 30 degree, if you see it's like a clock. If you place it at 12, 1, 2, 3, etc., you can see the fields will get cancelled with each other. Net field comes out to be 0. When you remove one charge, we'll just have the field due to the other charge on the opposite direction, which is unbalanced. So the answer for the 27th question should be option number 3. The 28th question, the orbital angular momentum of electron in the first and second excited states of hydrogen atom is given. According to Bohr model, you need to calculate the ratio of L1 to L2. We know according to Bohr angular momentum is quantized, which is nh by 2 pi. First excited state is second orbit, second excited state is third orbit. Since h by 2 pi is remaining same in both, so it's directly proportional to the principal quantum number. The ratio will be 2 is to 3 because it's a second and third orbit. They both correspond to what is given in the question. So 28th one comes out to be option number 4. Now moving to 29th one. 29th one is a direct question of logic circuits. First one we can see it's an NOR gate and second one is a NOT gate. If you not a NOR gate, you will get an OR gate basically. So answer for 29th one is option number 1. 30th one, strong magnetic field is applied along direction of velocity electron. The electron would move along a circular path, a helical path, the original path, a parabolic path. It will move along the original path. Why will it move along the original path? Because here the magnetic field is along the same direction of the electron. Therefore q v cross b is equal to 0 since v and b are in the same direction. So force experienced by electron is 0. So there will be no change in the direction of motion of the electron. So therefore it will move along the original path. So 30th one is option 2. Now 31st question, a string is wrapped along the rim of a wheel of moment of inertia 0.1 kilogram meter square and radius 10 centimeter. If the string is pulled by force 10 Newton, then the wheel starts to rotate about the axis from rest. The angular velocity of the wheel after 2 seconds. Here is a wheel. Here it's a wheel. And if we assume the string is like this, and we pull it with the force F, and we have a radius R here. We have a radius R. We know the torque applied by the force F is equal to R cross F about the center of axis of the wheel. I'm assuming it's about the center that the wheel is rotating, that is about its axis. So the moment of inertia of the wheel is given as 0.1. We know torque is equal to I alpha, which is equal to R cross F. So alpha, I get it as RF by I, and R is given as 10 centimeter. I take it in SI unit, so it's 0.1 meter into force, which is 10 by 0.1, which is the moment of inertia. So I get the angular acceleration as 10 radians per second square. Now if I use the first equation of motion in circular in terms of rotational variables, that is omega is equal to omega naught plus alpha t. Initial angular velocity is equal to 0 since it starts from rest. So final angular velocity will be alpha times t, which is 2 alpha. Alpha is 10, so we get the 31st question answer as option number 4. A stone is thrown vertically downwards with an initial velocity of 40 meters per second from top of a building. If it reaches the ground with a velocity of 60 meters per second, the height of the building. Height of the building, we can do it as V average into time taken. Here average velocity is equal to final velocity plus initial velocity by 2, because it's a constant accelerated motion. So 40 plus 60 by 2, which is 100 by 2, which is 50, which is the average velocity. And initial velocity is 40 and final is 60. Using the first equation of motion, we get as 60 is equal to 40 plus 10t. Using the downward direction as positive. So we get time as 2 seconds, which it takes. So we have average velocity is 50 and time taken is 2 seconds. So the average velocity into time is nothing but the displacement, which gives us the height of the building. So the answer is option number 4, which is 100 meter. Now moving on to the 33rd question. Rain is falling vertically downward with a speed of 35 meters per second. Wind starts blowing after some time with the speed of 12 meters in east-west direction. The direction in which the boy standing should hold an umbrella. Rain is falling vertically downward with speed 35 meters per second. Let me take this as the north, south, west, east direction. And if you see, the wind is blowing in the east to west direction with a velocity of 12 meters per second. So the net direction of rain will be in this direction. Velocity of rain net. This is velocity of rain with respect to wind and velocity of the wind. So the person holding the umbrella should hold the umbrella direction opposite to the direction in which the rain is falling. So basically he should hold it at the same angle at which the rain net is making the vertical or with the horizontal. The angle with the rain net is making the vertical, let's call it as theta. Tan theta is nothing but velocity of the wind by velocity of rain with respect to the wind. Velocity of rain with respect to the wind is 35 meters per second. Velocity of wind is 12, so 12 by 35. So theta is tan inverse 12 by 35 with respect to the rain, not with respect to the wind. Why do you say with respect to the rain? Because the rain is the vertical and the wind is the horizontal. It will be tan inverse 35 by 12 with respect to the wind. Now, moving 34th, we know that for electromagnetic waves, the E cross B, cross product of electric field and magnetic field gives the direction of velocity. So E cross B is equal to velocity vector. So the magnetic field must be in the I cap direction, because J cross I comes out to be minus K cap, which is the minus Z direction. So magnetic field must be in the I cap direction, and we know the magnitude of magnetic field is nothing but the electric field vector's magnitude by the speed of light, which is 3 into 10 power 8. So 3 by 3 into 10 power 8, we get it as 10 power minus 8, which is 10 nano Tesla. 10 power minus 8 Tesla, which is 10 nano Tesla. 34th one is option number 1. 35th question. In a photoelectric experiment, blue light is capable of ejecting a photoelectron from a specific material, while green light is not able to eject a photoelectron. Ejection of photoelectron is also possible using the light of color. We know here blue has a higher frequency than green light according to Webb-Gear. If blue light is only able to eject a photoelectron and green light is not able to, that means the threshold frequency is greater than the frequency of green light. And let's assume to be equal to blue light, or blue light is greater than the threshold frequency. So obviously a light which has greater frequency than blue light should also be able to eject electron. Here the only color of light which has a greater frequency of blue light is violet light, so that's the answer. Others all have lesser frequency, so they cannot eject an electron. So this is the end of section A. I have solved section A of physics abroad paper. Tomorrow I will be releasing the section B of the abroad paper. Please like, share and subscribe, and join my Telegram channel for more questions being uploaded daily. Thank you.